we're going to be talking about, again, the PRINTF function. And today we're going to dive a little bit more into the task to find out exactly what do I need to do to implement a PRINTF function. I know you're going to read about variadic functions, you read about string formatting and everything, but how do we even start? Where do we start from? And that is mostly what we're going to be doing today. Okay, if you are ready, let's just go into it straight without wasting any more time. Okay, the first thing that you need to give attention to in writing your own PRINTF function, like I mentioned yesterday, is string formatting. Okay, so if you know how to format string, then it means that you have a fair idea of what the PRINTF function is supposed to do. Because what it does is that it formats the string and prints it to the standard output. That is what you're going to do, right? So I'm just going to go into my error note, and then I'm going to go into the sketchboard, see if we can see the code today. Just let me read a few things in this slide for you, and then go straight and do that. The first argument of the PRINTF function is the printf. It has to be a format string, right? Then the string is going to be examined character by character, looking for specific patterns. Now, once the format specifier is identified and any modifiers are processed, the function extracts the corresponding argument from the argument list. Finally, the function formats the argument based on the format specifier and any modifiers, then outputs the formatted result. Now, what do I mean by that? The function that we are trying to create is a PRINTF function. Alright, now, this PRINTF function takes a list of arguments and then print it to what is known as the standard output. Because the standard output has a figure that indicates that this is the standard output. So this PRINTF function can take a variable number of arguments. That's why it's a variadic function in the first place. But the interesting thing about printf is that the first argument that it takes is a format string. And this format string is always in quotation marks. That is why if you try to print something, let's say you print in your code, printf, and you bring the parenthesis without quotation marks, it's going to read an error. That is because the first argument that the printf function expects is a format string. For instance, if I go into my VS Code, so just to demonstrate what I'm saying, I'm just going to write out the basic structure of a C program. We're going to use it to code. Just a moment. No, Ravna is going to tell me to write Betty compliant code, but I don't have the time for that right now. You already know what to do with it. You already know what to do with Betty, so please write Betty compliant code. You know what to do. I'm not the one coming to teach you about what to do about Betty. Okay. So assuming I want to printf, and I bring parentheses without any double quotes inside the parentheses. Now when I run this code, it's going to give me an error. So as you can see, it's indicating that something is supposed to come in here, meaning that the first argument that the printf function expects is a format string. So if I bring a quotation marks now and run this code again, nothing is going to be printed to the output node. As you can see, nothing is being printed. However, it's not giving me any error because at least it understands that I've given it the first argument, which is a format string. So when you're about to create your own printf function, the very first thing that you need to give to your printf function is a format string. And that is why the printf function has the prototype that it possesses. Okay, so that is well understood. Then you need to also understand that the way a string is represented in memory is by an array structure. Okay, that is why sometimes when we are declaring strings, we are like car, then let's say the name of our string is string, str, then we declare an array, and then we are like, this is probably going to be equal to Ernest. As you can see right now, you realize that my Ernest is in double quotes. That's because it's a string that I'm giving to this variable. That's the value I'm initializing to this string variable. And this square bracket you see over here is indicating that this variable with a character data type that I've declared is an array. And in memory, the way a string is represented is such that an initial null character is put at the end of the string. So assuming the string I declared is Ernest, this is how it's going to be represented in the memory. So it's going to be Ernest, and even though you didn't add any null character to the string, the compiler automatically is going to assign a null character to the end of the string. And this is what tells the compiler that, okay, so the string is over. So when the compiler is reading the string and comes across this null character, then it understands that this is the end of the string. This is very important to understand. I need you to take note of that because you're going to need that in writing your code. All right. So the first thing is that we have understood what a format string is. Now let's just delve deep into what string parsing. I'm not talking about P-A-S-S-I-N-G. I'm talking about P-A-R-S-I-N-G. String parsing. All right. We are not passing the ball. It's not like we are passing the ball. We are parsing the string. Right. String parsing. Let me go pick a few names in the chat box and let's see what we can use. Let's use Nwosu. I like the name Nwosu. Okay. And let's say I write a function, or let me not even write a function yet. Let me declare a format string. Okay. So I'm going to say it is a constant, meaning that it cannot be changed. The data type is a character. And then let me give the name of, or let me call the string string. Okay. And I'm going to indicate that it's a pointer. So I'm just gonna bring the asterisk you see over there. And I'm gonna see that this string is equal to Nwosu. All right. What does the compiler do? The moment you do this, the compiler understands that you are about to format a string. So the compiler starts parsing the value of the string. What do I mean by that? It's gonna come to n and check what is this n. It realizes that it's just a usual character. So then to print n, it will jump to the next character. What's this? It's like W, it's a usual character. It's going to do that over and over. So right now what I'm doing is that I'm scanning the string in here individually. And I realize that the string passes the condition and I'm going to print it to the standard output. So now I'm going to check for all the values of the format string. I realize that they are all just usual characters. And I'm going to print everything to the standard output. Okay, when I talk about the standard output, I'm just referring to your terminal or the interface. That text is output to. So when I talk about the standard output, I'm only talking about the terminal. So if I run this code right now, all the things you are seeing down here are coming from the standard output. So the instructions and the outputs, you see everything you see over here, they are coming from the standard output. It's like a location within your computer that gives the output of the instructions you've already given to your computer. Basically, that is the standard output. Okay, so now assuming you create a format string, and this time around it's not just a usual string, it is actually a string that has placeholders. The compiler is going to do something. So this time around, let's create another format string. It's still a constant, and then the data type is a character. And this time around, let's change the name and let's call it format because I'm about to take you into PRINTF, right? Then we're going to see that this string is equal to Leo is %s, okay? Quotation marks. The moment the compiler sees this, it understands that, all right, you have given me a format string, all right, but let me start parsing the string. So to check what is L, it's a usual string. It's gonna print it to the standard output. We'll check for this, check for this, check for this. The moment it comes to this one, it sees the % sign. It knows that, wait, I'm about to receive a special character. So the moment the compiler sees the % sign, it knows that, wait, I need to be careful here because the user is about to give me a certain instruction that will determine what I'll do next. So now all the other characters are usual characters. But the moment we come to the % sign, the compiler knows that this is a placeholder. So it allocates memory for that placeholder and then continues. It's like the next character that comes is what will determine what it will do. It could be a D integer, be an S for string, be a C for a character, it could be an X for a hexadecimal number. Whenever I'm seeing a hexadecimal number, I really struggle. All right. So there are lots of format specifiers. Now, the moment the compiler sees a % sign, it knows that the next character I see is what will determine what to enter this placeholder that I've assigned memory to. Then now you can pass the argument that this placeholder is supposed to go to the compiler. So this placeholder, I'm going to tell the compiler that put to rich over there. Then the compiler will take the argument and come and fill it in the placeholder that Leo is rich with an exclamation sign. Okay, so let's go do that in our code. Okay, so this is what I'm talking about. So constant with the character data type. Let's call our string format. You can call it anything though. I'm going to tell the compiler that Leo is what? %s. Then the compiler knows that this %s that I've given to it is a placeholder. So I can later come and say that printf, I'm going to give my compiler the argument, this function. So I'm going to say printf, the format string, the format that I give to you. Now I want you to print it out. And then for the placeholder in there, put in the text rich. Okay, so I'm just going to put in quotation marks. Then now when I run this code, you're going to realize that the compiler is going to print the text Leo is rich. I have a segmentation for because I didn't bring my pointer. Sorry. So let me print the code again. And the compiler says that Leo is rich. This that I just explained is the backbone of your printf function. You're going to understand why I'm saying that. The way to format strings, the way to parse string is the backbone of your printf function, because you are supposed to write the logic such that the compiler will take the string one character at a time. So I'll take this character and check, is it a special character? No. Take it to the standard output. I take the next character, is it a special character? No, it's not. Take it to the standard output. I take the next character, it's a % character, it's special. What do I do next? If the character is special, then check the next character. So if it is a % sign, go to the next character and then check which character it is. If it is an S, print the entire string to the standard output. If it is a D, print an integer. If it is a C, print a character. This is the code that I'm writing. So the statement and the explanation I just gave is what we are going to use to create the printf function. And it is as simple as that. So let's go do it actually. Let's go into the program and write the printf function for sure. Before that, let me see if I have any more things to share with you. All right, now this is another very important one. So remember I was talking about the standard output, that is just your terminal, the place where the instructions or the output test is taken to. Okay, now the first thing you need to do in implementing your own printf function is to find a function that can write text to the standard output apart from printf. What printf does is that it takes the formatted text, gives it to you on the standard output. But here is the case, you are about to create a printf. So you cannot use printf to create printf. I don't know if ELX allows for that, but it's actually doable. You can use the same printf function to create a printf function. But I don't think that is allowed in the project. If it were allowed, it would have been very easy. But since we are not going to use the printf function, now you need to find an alternative function that can also print a text to the standard output. And I hope that is very clear. So there are several options that you could use, but then the most common options or functions that can print formatted text to the standard output are 1. Write, 2. fput, then the third one is our beloved putcall. I remember that for most of the earlier projects, ALX will tell you that don't use printf, use putcall. For which reason they gave you the putcall function. Sometimes you have to write the putcall function on your own. So now you need to come up with an alternative function that can replicate the function of printf. And these three functions you see over here are very powerful functions that can do that. However, they all work differently. So depending on what you choose to write text to the standard output, that will determine the logic and the syntax of your code. I'm going to repeat that again. Depending on whether you choose write, fput, putcall, or any other function that writes text to the standard output, depending on what you choose, that is what will determine the logic of your code to output the text to the standard output. Now, if that is clear, the next thing you need to do write your printf function is to manage your header files. So before we come to the header files, let's go and write some code concerning this particular one. That is for the standard output. Then we'll come back and talk about header files, right? So I hope everybody's here with me. Can I get some feedback?
Yeah.
So now we're about to choose the function that we'll use to output text to the standard output. For me, I always go with write because it's very easy to use for me. The F-put is also easy to use. You already know about putchar, but the problem with putchar is that it will only output a character at a time. That means that you have to do a lot of looping, for loop, while loop, to be able to print a lot of things. So I don't prefer putchar because you have to loop through everything before you're able to print text. But as for write, all you have to do is to assign the output stream, then you allocate the memory. This is very easy to do, don't get confused. I'm not even going to take you to malloc. No, the moment I jump into malloc, you're going to probably be in trouble because a lot of people have not gotten comfortable with malloc yet. So if I start going to malloc, you may go overboard, but I'm not going to use malloc. But one thing that the write function does is that you determine which output stream you are taking it to, give the variable name, and then assign the memory that is going to hold the value of the variable. What am I talking about? So to use the write function, all you have to do is to bring the thing right, then the syntax or the value to indicate the output stream or the standard output for write function is the figure 1. Then you bring the name of the variable. So if I say $C, then that means that it's indicating the address of whatever the variable name is. This could be anything. This C I've written here could be anything. So I can see C. And the next thing I'm going to allocate is the memory. The amount of bytes, let me say the amount of bytes that the function. Now, if you took particular notice of the putchar function, you're going to realize that this is how the putchar function was created. The write function was used to create the putchar function. And this is what it does. Let me just shut this down. I'm going to read a text to you about the write function. Then I'm going to continue what I'm saying. I'll come back to this in a moment. So when I'm done, I'll just share this notebook on the WhatsApp page so that you can take your time and read it, because I can't read everything in here right now. We don't have a lot of time. So I said find a function that can write to the standard output apart from PRINTF. The option I'm going with is write. Okay, so the write system call allows you to write data directly to a file descriptor. The file descriptor for the standard output is typically represented by the integer value 1. You can use the write function from the Unix standard.h header file to write data to the standard output, right? So the way to do it is to, let's say if this is the format string I want to take to the standard output, I'm going to use the write function. Then this 1 over here, as I've already mentioned, indicates the stream, the file descriptor to the standard output. This $C is just indicating the address of whatever value you're going to give to write. Then the next over here is going to be the amount of bytes that you're going to allocate to the value of the variable you're going to print. Don't get confused about that at all. It's very simple. So assuming I want to print this string, all I'm going to do is say write to the standard output, and then the string I'm trying to print, the name of the string is what? String. As you can see over here, the name of the string is string. So I'm trying to print this string to the standard output. And how many bytes will I allocate to it? Let's count. Every character is 1 byte. As you know, 1 character is 1 byte. An integer is 4 bytes. A double is 8 bytes. These are basic things we've already learned. So for this string over here, each character is 1 byte. So I'm going to say 1, 2, 3, 4, 5, 6, 7. And then the now character 8. So I'm going to allocate 8 bytes to this thing. And if I do this, I'll be able to print this string standard output. So assuming this string was a long string, long string, I'm not going to have the time to count 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to waste a lot of time. So the best thing to do is to use a function that calculates the length of a string. Then I'm going to pass that function to this variable, and then the function will calculate the length of a string, and that's what will determine the amount of memory that will be allocated to the write function. So basically, one of the if you have taken your time to read through the string functions, you know that one of the functions of the string function is string length. That's strlen, which calculates the length of a string. There are others like string copy, there are others like string compare, there are others like several string functions. But the string length calculates the length of a string. So you could even decide to use that in your printf function, depends on what you really want to do, or you can write it from scratch, right? So you can just give the name of your variable str to the string length function, then you have assigned memory. This is how the write function works. You can take time and read on it, find out what it does. Or you could also decide to go with fboots. I'm not going with that. It's very simple to use too. Or you could also decide to go with your beloved bootcamp. That's also very simple to use too. So now that we have chosen the function that we are going to use to write to the standard output, what is the next thing that we're going to do? The next thing is to manage your header files, right? So here in our code, we are about to write a printf function. How do we start? Let's start from scratch. So writing the printf function, you clone the repository. What is the next thing you must do? Your partner, you created your readme.md. Now, what is the next file you're going to create? Let's start writing the printf function now. Let's go to the printf function and start writing it. You've already read through the requirements and everything. I'm not going to do that again. Yesterday we went through the test, so we're not going to talk about that again. So let's start writing. The first tag says that write a function that produces output according to a format. And the prototype was given, we've already perused it yesterday. And as you can see, the same syntax that you use to write a format string is what is the parameter of the printf function. That is why the first argument of the printf function is a format string. So the moment you see printf, it is expecting a format string first. No stress. And then this function is supposed to return the number of characters printed. That means that if you say print, let's say Bena, the printf function you write is supposed to be able to return the number of characters. So 1, 2, 3, 4, 5. So it's going to return the integer 5. Okay. If you print Osu 1, 2, 3, 4, 1, 2, 3, 4, 5. So it's going to return 5. Okay. Now, remember that we've already spoken about a function called string length that is able to return the length of a string. Or you can decide to write the string length function from scratch. This simply means that you're writing your printf function according to the instructions that you were given over here. The function must include a logic. Whether you are going to borrow the string length function from the string.h header file, remember strings. Whether you are going to borrow the string length function from the string.h header file, or whether you are going to implement your own function that calculates the length of a string, ALX doesn't have a problem. All they want is that at the end of the day, your function should be able to return the number of characters printed by a string. And it's supposed to exclude the null byte used to end output to the string. Remember I told you that at the end of every string, there's a null character. ALX is saying that don't include the null character, right? Then we are going to write our output to the standard output string. We have already decided, we have chosen the function that we are going to use to do this. And I went with the write function. You can choose any function that you want. There's no problem with that. Just make sure you don't use printf, anything apart from printf. Right? And the next instruction says that format, which is over here, format is a character string. You already know that. So this is a variable and they are telling you that it's a character string. Then the next instruction says that the format string is composed of 0 or more directives. 0 or more directives. What does that mean? Now simply, if I come and I say that Leo is hot, all right, Leo is hot, in quotation marks, this is a string, all right, but this has 0 directives. There are no directives in here because the function is just going to return each character as it is. This string has 0 directives. But assuming I come here and say that, let me go see somebody. Who can I see here? I see Benjamin, I see Ishmael. Ishmael, you're welcome. Been a while. Okay. So assuming I come here and I see that Ishmael is %s, and I close my quotation marks. I have 1 directive in this string. Okay, so ALX is saying that your function can contain 0 or more directives. This one has 0 directives because there's no instruction in there. This one has 1 directive because it has 1 format specifier. So this one has 1. And I can tell the compiler that this %s over here, it should put back over there. So when it goes to the output, it's going to print Ishmael is back. So you're going to see the %s is a single directive. Assuming there were 5 format specifiers in the string, then there are 5 directives in the string. So that is basically what that instruction is talking about. You're going to need that in writing your code. Then the next thing says that man, as for man, you know what to do about it. Then the next thing they're saying is that you need to handle the following conversion specifiers. For the first task, only C and S and the % itself. You don't have to reproduce the buffer handling or the C library, no need. No need for flags, no width, no precision, no length modifier. That means that this is a very simple task. The moment you do this, you have 50%. So let's go and do it. Now we're about to write our printf function. What do you need to do first in writing your printf function? The first thing you gotta do is to import your header files. No doubt about it. No doubt about it. All right. Okay. So now, but remember that you cannot just put your header files anywhere. Here in this case, ALX has instructed you that your header file should go into main.h. Okay, so it says that your header files are supposed to go into main.h. All right, so the immediate thing you're going to do is that first, you're going to create a file known as main.h. So let's create main.h. Okay. This main.h file is, as you know, going to contain the prototypes of all your functions, as you've already been doing, including all the header files you have to import, including everything, every prototype. As long as there's a function, the prototype must represent in main.h. This is not new to you because you've been doing C for a while. Okay, now, next, we are about to create our printf function, but the header file, we don't want to put the header file in the our source file. Okay, so this source file underscore printf.c. all right, so this underscore printf.c is going to contain our header file. We are going to include, this time around we are not going to include this because it's a custom header file. It's going to be in quotation marks, so we're going to include main.h. okay, you already understand this, and this is your printf underscore printf.c file. Then inside the main.h file, you now come and include your prototypes. So for this one, the immediate function we are about to create, remember I spoke about functions like string length and all that. So all those functions, to use them, you need to include their header files in main.h. So what I'm doing right now is that I'm teaching you how to handle the header files. Everything you're going to do in your main printf source file, bring the prototypes and the header files into main.h, and then include the main.h itself in your C source file. So you're going to go include main.h. So this is my C source file. Okay, amazing. Now, the next thing you need to realize is that this main.h header file is going to contain a lot of information. Okay, so that means that when the compiler is working, it is going to be calling the main.h file several times. This is what I mean by that. Now you need to hear me out carefully. Assuming I want to create a function that's going to handle the precision, I'll create a file, let's say precision.c, and I'll put the function in there. Then I'm going in that file precision.c, I'm going to include main.h. Assuming I wanted to create another file to handle the width, I'm going to create another file, maybe width.c. Okay, but inside that width.c file, I'm going to include main.h. This simply means that for every file that you are going to create in the project, main.h is going to be included. And this can cause problems because the compiler will get confused. That why is it that I keep going back to main.h, I keep going back to main.h, you keep including main.h, and that can cause undefined behavior. And this is what leads you to what is known as an inclusion guard. Inclusion guard. The inclusion guard is what ensures that when the compiler comes across the main.h function, main.h file several times, it's going to keep skipping it because it knows that it already has the main.h file in its memory. So it's not going to keep evoking the main.h file over and over. This is what is known as an inclusion guard. So if you look into the requirements of the project, they are going to say that include guard your file. It says that all your header files should be include guarded. And we have already spoken about this a few weeks back when I was teaching you guys about functions. To include guard your file, so this is my header file main.h. How did I teach you guys that you can include guard your file? I want somebody, or I'm going to call a name. How do you include guard your header file? Anybody can just unmute and say it for me to type it in.
Understood.
Okay.
Then you cut.
All right. Q. Is that all?
The 25 is not something for the answer.
Are you sure it's if end? You did well. I mean, you did well. You've done very well. Okay, so this is how you include guard your file. Now, ALX is saying that I think somebody got to mute their feed. ALX is saying that you include guard your header files, and this is how you do it. This simply means that if the compiler encounters the main.h file, it's going to find out, is the main.h file defined already? So if it is not defined, it will define it. So if not defined, define main.h. But if it is already defined, it will skip. At the end of the day, it's going to end it all. Okay? And the prototypes are all going to come in here. Right? We're solving it together. So this is how you go about the project. Now, inside the printf function itself, remember that you've been given your prototype. Okay? So, as usual, you're just going to copy your prototype. Your prototype of the prototype of your printf file is definitely going to go into the main.h as well, because it's supposed to contain all the prototypes. Wonderful. Very simple. Int printf, then this is the prototype of your function. So we put that in the main.h file. Then in your printf.c file itself, you're coming to write the function for printf itself. And as I explained to you initially, printf is going to take a variable number of arguments, meaning that you need to use the syntax of a variadic function. You're going to use the syntax of a variadic function. So we are going to pseudocode together. So what do you do first? Remember that we are dealing with variadic functions.
I like the I'm guessing you're right. If I'm guessing about one, without having the conflict in my plane.
You have to declare the variables. Initializing them means that you're giving them values, but declaring them means that you are starting your variables, but you don't have values yet. So you declare some of them, initialize. Fractal, you did great, amazing. So let's go and then initialize whatever variables. Now this is where people fall into trouble, okay? So just like Prince said, all you have to do when you start out is to just declare your variables, okay? So let's declare some variables. Let's say we're going to, now this is where people fall into trouble because they go and copy and they even use the same variables. But the variables, you can name it yourself as long as they are descriptive enough. So anything at all is okay. Now we can declare that we are about to print some characters. So let's say characters to print. This is a long variable though, but at least you have a fair idea of what I mean. We are going to print characters and let's initialize it as 0. I'll tell you why we need to initialize it as 0. Then if you have watched the video about variadic functions that was put on the page yesterday, and you know that if you're going to deal with variadic functions, then the first thing you need to do is to get the list. All right, you're going to use a variable argument list to get the list of the arguments that you're going to take. Because remember that the printf function is going to take multiple and variegated arguments. We are going to use a variadic function to get the list. So this is a variadic function list, and then you can name your list anything. Okay, you can name it a list anything. You can just say a list of arguments. However, before you use the variadic function, there is a header file that allows you to use its sub functions. who can tell me what that header file is?
I think that I think
All right. You're right. It's correct. Okay. So just like I explained to you, all your header files must go into the main.h file. So now I want to include an additional header file. So I just come into my main.h file. I'm going to include my standard argument.h header file. As you can see. Lovely. So then now when I go back to my source printf file, it's going to allow me to use the variable argument list. Realize that initially it was saying that there's an error, but now that I've gone to include the standard argument.h header file, now I have the permission to use one of the functions of the variable argument header file. Just in the same way, if you want to use printf, you have to go and include standard input and output.h as a header file. If you want to use some of these functions, you also have to include the standard argument.h. That is very important. And then this standard argument.h has 4 main functions, which is variable argument list, which you have seen. The next is variable argument start. I spoke about these briefly yesterday. The next is variable argument. Then the next is variable argument end. But the question is, how do you use these functions to implement your printf variadic functions, that function that you're trying to create? Now you have used this variable argument list to initialize. You have used it to initialize the list of arguments that you're going to take. So see this like a data type, all right? You have created a data type that is supposed to take a lot of lists, all right? So now you have created the variable argument list, okay? You have included the variable argument header file. Then it allows you to use the variable argument list. This variable creates room, right? So it's going to assign a lot of room. That's going to take any amount of list that you can give to it. What you've done is that basically you have made room for a list of many things that you're about to receive. So that room is infinite. It's there. Anything you want to add, just keep putting them in. That is the first thing that this does. But the moment you initialize the variable argument list, it doesn't mean that there is something in a room that you have created. Initially, it's an empty room. Okay, there is nothing inside it. The moment you do this, now you need to start putting things inside it. And to put things inside the room that you have created, that is when you now call the variable argument start. Okay, that is what you use to put value inside the room that you have created. It's very simple. Don't let it confuse you. And if you take your time and watch more videos on variadic functions, all these things will start coming alive to you. So first, we have created our room. We have called the room the list of arguments that we are about to receive. That is very simple. The moment you receive the list of arguments, you can now start with your logic. Okay, and we're going to see that now that I've created room and I'm about to receive input here, what if the input that someone comes to put in here is a wrong input? Because we have certain kinds of data that we accept in this household. If you bring the wrong data into this household, we are not going to accept it. So right there, you know that you have to bring some conditions to rule out any invalid data. So the next thing you're going to do immediately is that you're going to say that if an invalid data is given as an argument, what do? I end the program. So I'm going to say that if invalid data, this is just pseudo, then program should end. How do you implement that in code? Think through it. So let's say if somebody gives a null data, so someone says printf and does not put anything in, then that means that an error is supposed to be printed. The program is supposed to end. So that means that your code logic should implement that first. That the first thing you need to do is that if someone tests my printf function with an invalid data, the program should end or an error should be printed. You know that the way to print an error to the standard output is to use -1. So in pseudocode, how would it even occur to you? How will it come to you? Let me just help you out because there's a lot to do. So you could say something like if your string, whatever name of the string is, here in this case, the name of our string is format. So you can say something like, if the format an invalid data, like what now, then what are you gonna do? End the program. So you bring the code logic that ends the program, or you return an error and say return -1, or whatever you want to say, print whatever, put car, whatever you want to do. So the first logic is that you are thinking through pseudocode. I'm about to create a function. What if the first value that is put in is an unacceptable value, or it's a null value? Then the first thing you want to do is that return an error. So if the format is null, return an error. Very, very simple structure. You come into your code and say that if the name of your string is null, then simply return. I'm going to handle one format specifier for you so that you have a fair idea of how to handle the other format specifiers. So I'll handle one format specifier for you. So the first thing I'm saying here is that if my format is null, then I want to return -1 to indicate that it's an error. Then the next thing I want to do is that, okay, so let's start receiving the other arguments that our function is supposed to take. And just like I told you, you use a variable argument start to receive argument. That is what you use to initialize argument. So how do you use the VA start? Think about it like a data type. Think about it like a function. So you're going to use the VA start to receive your list of arguments, which you've already declared. So list which you've already declared over here. After you list your arguments, the next thing you want to do is to indicate that the last parameter, or the first parameter that this Variadic function is going to receive, is your format string, which is this. So whenever someone is going to input data into your function, the very first argument that they should give is what has been indicated here, which is a format string. So after you initialize your list of arguments, you want to bring the last value over here. The last value in your initialization should be the first argument that is passed to your PRINTF function. Very simple. And I just hope you're writing this down, because you're going to need it for the rest. Okay. Now, the next thing you want to do, right now we have used VA list to declare arguments. You have used Variadic argument start to receive the list of our arguments. So now let's go into code and see what next can we do, right? So we can start thinking through. We're going to see that while we are inspecting our formats, so I just started a while loop. While we are inspecting our format, remember that I spoke to you about string parsing. Okay, so the compiler is going to take the arguments that has been given to your PRINTF function one character at a time. So what I'm saying here is that while we are inspecting the entire string, if that is where the if else statements come in. You can use a switch statement, you can use an if else statement, or whatever suits you. While we are inspecting our entire string, if it is S, do this. If it is C, do this. If it is whatever, do that. But the first question that ALX was asking was that we should handle output to the standard output stream. We should handle C, S, and then the % sign. Let's try and do like let's try and meet a few of the rules here. Then you go try the rest on your own. Okay. So I'm gonna say that if our format is not 0, if our format is not the % sign, because remember that the moment it encounters the % sign, it's supposed to check for the next character. So if our format is not the % sign, then it's supposed to let's say I'm writing Ishira or whatever, I'm writing Leo. The compiler is going to parse and check, is this the % sign? No, it's not. So if it's not the % sign, let me take it to the standard output. Is this a % sign? No, it encounters the % sign. If it is a % sign, I'm going to check for the next character to see if it's a C, an S, or a D, or whatever. So now the logic is that if my string is not the % sign, then let me take it to the standard output. And the function that we have chosen to take our characters to the standard output is write. And I've already explained to you what the write function does. So I'm going to say something like write to the standard output. The standard output for the write function is represented by 1. Then what am I writing to the standard output? I'm writing the name of my format. So I'm writing format, the string or whatever it is, to the standard output. Because it is not the % sign, we are dealing with a single character. So I allocate 1 byte to it. So basically what this logic is saying over here is that if my format or the string I'm inspecting or parsing is not the percent sign, let me put this in a character. So if it is not the percent sign, write it to the standard output. And this is a very simple logic. What do I do next? Now I've handled the situation of all the characters of the format string that are not percent sign. So I'm saying that if the string is not the percent sign, then write it to the standard output. But what happens if it is a percent sign? Then that means that else. So if it is not a percent sign, do this. But if it is a percent sign, then what are you going to do? So that is where the else statement comes in. So if it is the percent sign, what do you do if it's the percent sign? The first thing you want to do is that you want to check the next character. That is how you think when you're coding. It's like, I'm giving it to you. ALX is going to hate me, but no, I'm not giving it to you because you have 1,001 things more to do. I want you to at least have a fair idea of the logic that you're supposed to implement the rest of the things that you're supposed to, 1,000 more things you're supposed to do down there. So we have checked our character. It is not the percent sign. We're taking it to the standard output. So as it stands now, on the standard output, we have Leo printed. Okay. Then now we are checking the next character and realize that, okay, now it is the percent sign. So what do we do now that is the percent sign? That is where this code comes in. If it is not the percent sign, write it to the standard output. Else, if it is the percent sign, then what do you want to do? You want to format it. So you want to move to the next character. So format increment. And remember that we've spoken about the increment operator. What it simply does is that it checks for the next. It increments a figure by 1. Plus increments a figure by 1. So now that we are inspecting or parsing a format string, when we say the string plus, we are saying that go beyond current value in which you are to the next value. So if it is not the percent sign, then what is the next value? That is what the syntax over here is simply saying. So now we come to the next parameter and it says that now we have moved to the next. So if our format is a character C, what do we do? Because we are supposed to handle C, S, and the percent sign for the first task. If our format is a character C, what do? You're going to write the code that prints a character to the standard output. If your format is a character S, then what do? You're going to write the code that prints stuff to the standard output. Every character must go in quotation, single quote. Make sure you take note of that. If your format, the character, then what do? Write a code that skips the percent sign. This is a logic by which you're going to write your PRINTF function, at least for the first task. But remember that when you are dealing with the character for printing out a string, which is the S, you are supposed to use a function that also calculates the length of the string. Then the question is will determine whether I'm going to continue or not. Okay. So if you have any question, just go ahead and ask.
PRINTF is not a person expected. It's perfect. And then after passing it, that's towards expressing love, so this is after that's the argument.
Yes, you are definitely going to add the str length as long as you are going to calculate the length of a string. Or you may choose not to even use the str length. No, the str length is not in every case, only for when you are implementing the string function. Okay, it's only when you are implementing for %s. I hope you get it. And then you also need, if you are going to use a switch statement, then you need to know the syntax of the switch statement. If this, do this, or else break. If this, do that, or else break. And it's really simple and straight to the point. Why? Yes, at the end of the day, you have to make sure that you bring a default. Without a default, you're going to have an error. Remember that you are using Variadic function, so it is the VA arguments that you use to extract the actual arguments that you need to take. I think I need to do that because if I don't show you how to do that, it might get really confusing. So let me try and do that for one of them. So in order to do that, let's initialize. We'll use this character print variable. Use the VA list for the list of arguments. Then use the format. If our format is now, return -1 to show an error. Use the VA stack to receive the arguments that's going to be coming. You see that while we are inspecting the format, if the format is not the percent sign, then we write whatever character it is to the standard output. Then now we're going to increment the characters that have been printed. This character print variable that we have initialized because we are in a while loop, we have to implement it. So we're gonna say character. Okay. Then we're gonna see that else if our current iteration in the loop is the %sign, we're going to move to the next character. So we skip the %sign. And if the format is not a null character, because at the end of the day, a string is supposed to end with a null character. So still in this statement, if the format, before you even come here, you gotta see something like if format, which is your string, is not the null character, or rather if it is the null character, \0, then quit the parsing. You're gonna see something like break. So now, basically the logic here is saying that if your string is the character that ends the string, then everything should end. So this will even apply to the switch statements that you were talking about. That if the character, we are passing the characters, we are going from one step to the next, one step to the next. The moment we encounter the character that is like a special character, then let's end with the code. So the next thing we're going to see that if the format is, let's say, the character C, then we're going to use a variadic argument to extract whatever argument it is. Come and say, or initialize a variable or anything and say that if, let's say, int, whatever this might be, let's say number should be equal to variadic argument. We're going to use that to extract the list of arguments that we created. List of arguments. Then, what is a character? We're going to use either a char or an integer data type. So this is like me implementing the logic for if the compiler encounters the character C, which is a %C, that means I'm supposed to write something, a single character to the standard output. So I've initialized a variable which I've called now. I've used a variadic argument to extract the list of whatever argument that is going to encounter in the format string. Then the next thing it's going to do is probably to write the character to the standard output. So we're going to use the write function again. The standard output, right? And here in this case, we're going to use the string length function because we don't know the amount of string or the memory to allocate. So we can use the string length function to our number. That is to the arguments that will be given to it. And then if you are going to use the string length function, it means that definitely we have to go into our main.h file that include the string. Then back to our PRINTF file. Use the string length to calculate the length that we're going to allocate for the write function, which is very simple and straight to the point. Then let me get rid of this. At the end of the day, for variadic functions, you have to come and say variadic arguments, and you end a list of arguments, which means that you've created room. Now you need to shut the room so that the memory comes to an end. Or a list of arguments to an end. Yeah. Get rid of this. Okay guys, so I managed to debug the entire code, and let me run you through it to see what we have. So the first thing that we did was that we included a header file main.h, which contains all the prototypes of our functions, our macros, our inclusion guard, just as usual. We've already run through that. Then the next thing that we did was that we brought the prototype of our printf function, which takes a format string as the first parameter. Now this ellipse means that there are more arguments that can be given to the printf function that we are creating. Now if you look at one of the requirements of the function for the first task, it says that we need to return the number of characters printed, meaning that this return type of the function printf, this int is a return type. We're supposed to return the total number of characters printed by a format string after the entire function is done running. I hope that is very clear. So that is why here we initialize a variable that we call character print, and we initialize it at the value 0 because we are going to use that to track the characters that the function is going to print. Very simple. Then next we came to use a variable argument list of the variadic function, the header file standard argument. Okay, then we use that to declare the list of arguments that we're about to receive. Just like I explained earlier, so we have created room, we are about to receive a list of arguments. We have created like a large room where we can receive any number of arguments. Then right next after that, we now have to say that if our format string is null, then we are immediately going to terminate the program because it's going to be an error. We cannot receive null as a format string. So that is straight to the point, and there are no questions about that. Then next, we are going to use a variable argument start to now receive the list of arguments that the user is going to put into the function. Okay, and then the format string, that was the first parameter of our printf function, is now we are indicating that as the last argument of the variable start function. But before you use this, remember that you have to go and add that header file to your main.h file. So as you can see over here, inside our main.h file, we have included our standard arguments.h. That is what allows you to use Variadic functions. Okay, we are just going to come back to our printf file, source file, and continue going through our code. Okay, then right after that, we initiated a while loop, and we said that while format. What does this mean? This means that we have started a loop that is going to iterate through all the characters of our format string. I hope that is very clear. Then within the while loop, we brought an if statement. We are like, if our format is not the %sign, then we are just going to write whatever iteration that we are to the standard output. I hope that is very clear. So assuming we are trying to print a string Leo, so now we are going to pass through the string one by one. So the first, we are going to check the first character L, which is not the %sign. So we are just going to print it straight to the standard output. We check the next character E. It is not the %sign, so we just take it straight to the standard output. And that is what we are saying over here. If our format is not the %sign, then we just write it. We use the write function to write it to the standard output. And because it's just a character, we allocate 1 byte to it. Then the character print variable that we declared initially, we use that to track the number of characters printed. So we increment it. Then now we now bring the else of this if statement, that else, then we continue with the rest of the code. Meaning that for this if statement, we are dealing with a character that is not the %sign. Then for this else statement, we are now coming to deal with if the character or the format is a %sign, then what do we do? Now I'm about to minimize this whole thing just for a minute, okay? Because I want you to see something. I want you to observe something. That is what will let you see what is good. You're gonna realize that this while loop that we declared, every code that is all the way here down to when we implemented the format is inside the while loop. Everything that you are seeing over here, all the way down this format, is inside the while loop. Then this if statement goes along with this else statement. And as you can see, all the code that you see here is inside the else statement. You can pause the video and observe it carefully. So this simply means that this if statement is saying that if our format is not the %sign, we should just do this. Then this else statement is saying that if our format is the %sign, then we are now coming to implement all these conditions that handles the case of our format or our string being the %sign. So everything down here is taking care of the character being a %sign. I hope that is very clear. Then I'm now going to maximize it and let's continue with our flow. Okay, so now we are dealing with the character or the format being the %sign. If the character is the %sign and if it is the now, so listen to this. If the format is the %sign, the next thing you want to do is to increment the format. Now this simply means that we are skipping the %sign. So we are passing through the format string and we encounter the %sign. What do we want to do? We want to go and check the next character. And that is what this syntax is talking about. So if we check the next character and realize that is a null character, we are just going to break the code because the null character indicates that it is the end of the string. So we are just going to end. All right. Now, if our format is the %sign itself, Now, if the next character after the percent sign is the percent sign itself again, then that means that we are dealing with a double percent sign, just as you see over here. If that is the case, all we are going to do is that we'll print that symbol to the standard output. And if you look at the requirements of the task, you're going to realize that one of the cases that you're supposed to handle is the percent sign itself. So that is what this code is taking care of. This percent sign is taken care of by this code. So we write the percent sign to the standard output. And now we come down to handle another condition. We say that else if the format is a character C, which means that we're coming to handle the case of a character, what we're going to do is that we are going to use the Variadic argument va_arg to extract whatever argument that is going to be given to the function. I hope that is very clear. You should have had a very good foundation of Variadic functions by now, so this syntax should come to you. If you don't, I dropped a Variadic function video resource in my previous video. You can just check it and then make sure that you understand Variadic functions very well. So this syntax you are seeing here is a variable argument that we are using to extract the argument that will be given to the function if the case is a character. Then we write it to the standard output to the function write. And I've already explained this write function earlier. Okay, now we come and handle the case of if the character is an S, which means that we want to print a string. If it's an S, what do we do? And right here we declare a variable pointer, which is a string, and then we use the variable argument to also extract that argument, which is a string array. As you can see, it's a character pointer, which means that it's going to hold a string. All right, then we now remember that the function also says that we should return the entire length of a string, which means that we have to create a function that is going to calculate the length of the string. At this juncture, you could either decide to use the string.h header file and use functions such as string copy, string length, and all that, or you can use strlen string length to calculate the length of a string over here. But what I have done here is that I actually implemented it from scratch without using the string length function, but you can decide to use that. And the way I did it is that I initiated a while loop, and I'm saying that the index, whatever index this string is at, if that index is not a null character, then I'm going to keep incrementing the string. All right, so that is what the syntax you see over here means. We are going to keep incrementing the index until we hit the null character, then the loop is going to break. And when we are done, we are going to write whatever the number is to the write function, to the standard output. So this string length would have run its iterations, and then we'll have the number of, or the length of a string over here. And that is what's going to allocate the memory that will be used by the write function to write to the standard output. I hope that is very clear. Then finally, we now come and use the number of characters printed variable that we declared at the beginning to now equate it. So this syntax is simply saying that the number of characters will be equal to the number of characters plus the length of the string. I hope that is very clear. That is what this syntax is talking about. Now, finally, within the while loop, we are going to increment our format. Then the whole loop is going to run in the while loop until the condition becomes false. Then to end it all, we use the variable argument end to now close the window of receiving argument and to close out all leaks. Okay, then now we can safely return the return type of our function, which is the number of characters printed. It looks long, but it's actually really simple and straight to the point. And when I was done, now I wanted to put my printf function to the test, so I tried to print a simple string. I also tried to print a character with the format specifier C. I also tried to print a string with the argument string, and I also tried to print the percent character itself. And let's run this code and let's see the output that we get. So as you can see, our first output Leo is over here. Then our next output character V is also over here. Then our next output string is over here. And our next output, the percent sign, is also over here. Which means that this code you see over here, let me minimize it so that we have a panoramic view of the entire thing. So this code you see over here is actually what handles task number 0, which says that I am not going anywhere, blah blah blah. So we've handled all the conditions here. We've handled C, we've handled S, we'll handle the % sign. There you go with task number 0.